Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will be talking about discrete event simulation models. For example, let's consider a single machine, right? And we are saying that okay, this single machine is a failure-proof machine on the shop floor, fed by a buffer, and arriving jobs that find the machine busy must wait their turn in the buffer and eventually are processed in their order of arrival. Such a service discipline is called first in, first out, or first come, first serve, and the resulting system is called queuing system. Basically, the word queue is derived from French and ultimately from a Latin word that means tail, which explains its technical meaning as a waiting line. The diagram which you can see in slides is basically a schematic description of the system of FIFO, first in, first out. So to represent this system as a discrete event simulation model, first we need to define a state. So we can say okay, uh, state can be defined here as the number of jobs in the system at time t. So if I am saying s at a certain time t is 6, means uh, is equal to 6, right? Means that machine is busy processing the first job, and five more jobs are actually waiting in the buffer. So that's why the total number of jobs in the system at time t is equal to 6. um, about the events, right, for this or such particular system, we can say we have two state transitions or two events, arrivals and process completion. So suppose that an arrival took place at time t, uh, when there were, let's say, n number of jobs in the system. So what's going to happen if there is a arrival? Then there will be a state transition, and number of jobs in the system will jump from n to n plus 1, right? Uh, because there is a job arrival. Next would be, let's say, a process was completed, like a job was completed, right? From a job, I mean a product, and once it has been completed, that job will depart the system. So the process completion at time t will jump from n to n minus 1, because once the job is finished, uh, then that particular job will leave the system and the machine will start working on another part or job. So both transitions are implemented in the simulation program as part of the corresponding event processing. Second example could be single machine with failures. So consider the previous single machine like the same on the floor job, and now what we are doing, we are also including machine failures. So in addition to service time, as well as arrival, we also need to describe time to machine failures. And when there are machine failures, we definitely need to incorporate repair time as well, right? We assume that machine fails only while processing a job, and that on repair completion the job has to be reprocessed from the scratch. So this is basically our assumption in such modeling. So here the state s of t is a pair of variables. Before it was only n, but now it is n at time t and v at time t, right? So n is basically the number of jobs in the buffer as in the previous example. But here we are saying, okay, v of t is the process status. So is it idle? For idle, code will be 0, for busy code will be 1, and if machine is down the code will be 2 at all time t, right? um, Note that one job must reside at the machine whenever its status is busy or down. Okay, so here what I'm doing is the events are arrival, process completions, machine failures, and machine repairs, and the corresponding state transitions are given as under. So let's say if there is a job arrival, right, with every job arrival n will be n plus 1, and for the service completion it will be n minus 1, because once the service for a particular job has been completed, it's going to depart and leave the system. I mean, it's going to move to the warehouse. uh, for the failure occurrence, it will be n comma 1, and it will jump to n comma 2, because because when v is 2, this means that machine is down, and definitely we will be working on machine repair after failure. And then once the machine has been fixed, it will be working again, and the status will jump from n comma 2 to n comma 1, because 1 here at the bottom, you can see I am using this pointer. This one is basically the vt, and vt means process status at time t. So 1 is for busy, mean machine is working again, and 2 is when machine is basically down, this one. So when we have our repair, so it will jump from 2 to 1, means machine is now working. Let's talk about another example in which we are considering workstation subject to failures, and as well as control, inventory control. So